Perfect. All right. I'm glad to hear it, Chloe. Okay, so this is our first meeting. Obviously, you can go ahead and just hit the next one. We're just going to be doing introductions currently. My name is Dave Wilson. If you guys haven't met me yet during the last general meeting, these are some specifics about me. I have a focus in embedded systems. I'm a senior. I plan on graduating in 2021. Go and get to the next one. This is Sunny. That was supposed to be fixed. Go ahead and
Yeah,
introduce.
I'm your co-electrical lead. I joined Solar Car team like last year. Yeah, I plan to graduate in 2023, so I'm a second year and I don't have a focus yet.
All right, go ahead. Next one. The points of this meeting are rather simple. We're going to go over some schematics for the system and pretty much where to find it. So the cool thing that we have about solar car is that everything is like consolidated mostly. I'm gonna say mostly. There are some things that need to be cleaned up in there, but it's if you need to find something specific, it's fairly easy to find because it's all sectioned off pretty well. Here,
Can you see it?
there we go. Yeah, I can see it. Can everyone else see it? I'm gonna go with yes because that would normally make sense. So this is the base screen. You'd normally just go to your drives. If you don't have access to the drive, let us know so that we can get you access to that drive. I believe all we need is your email. So if you can just type it into Discord in the electrical section, that'll be a lot easier that way. And go ahead and Sunny, go and click into electrical. So in these sections, like I said, everything's kind of consolidated into different areas. Today we're going to be going into the where is it? Schematics. So top right and down. In here we have two very important diagrams. The first one is the system block diagram, which is you had it in
Look,
there you go. Not that one.
system.
The red one at the bottom.
Got it.
That one. Okay, and if you could zoom in just a little bit, that'd be cool. Oh, that's too big. It's too much.
Too much.
Okay,
Is that okay?
so system block diagram is a very interesting tool. It's basically like, how do you describe this? Like blocks of the subsystem being linked together, but with not too much detail. It's more of like this is the overview. We're not trying to get too technical on this one, but you can see also that there's a flow of interest. You can see how solar arrays really care about those maximum power point trackers. You can see that the BMS relates to relays, which will pretty much they're like switches, and we need. Sorry, BMS stands for battery management system. There's a battery pack. Everything's interconnected, but we don't want everything connected all at once, so that's why there are relays there. Um, and this is pretty good brief look at the solar car, like pretty much like a skeleton. If you go ahead and back out of this, Sunny, you can go ahead and go into the more in depth. This is the electrical schematic revision A. So don't be too intimidated by this. It's not too crazy. If you can attempt to zoom in again, Sunny, that'd be appreciated. And then go ahead and start on the left side. So all these are sectioned off as well. And we're going to start off in the solar array section. Keep in mind, I am a senior, but we haven't covered everything. I'm like maybe about 70% through my degree. So even I have stuff to learn. And don't be intimidated. Like I said, don't be intimidated. I still have to learn stuff. You will learn stuff along the way. And if you need to know something and you don't know it, I will help you out the best I'll help you. Okay, so if you follow the solar array, it leads all the way over to the maximum power point. Uh, maximum power point tracker. This is basically what I was reading up on it recently. Is basically solar panels do not get the full amount of energy that you would normally assume it would get. It gets about 35% of it. This allows you to get more, in a sense, by regulating. I don't remember what the words were, but it regulates how much power goes to the, or how much voltage goes to the battery, and those batteries get charged up in an efficient manner. That's basically what it is. If you go and continue more up to the top, you can see our battery pack. This is our lithium ion batteries. I don't remember the specific number of batteries that we have. Actually, hold on real quick. I'll go get a section of one because I actually have one here. Give me a second. This is like one of three, and they are humongous. They're all soldered together. This one in particular, did have some issues, and we're looking to repair it. Uh, but we're figuring out what the issue is first. But this is pretty much just one of, I think, three total packs of them.
Um, that is an interesting question.
All right. As you can see, we already talked about how there are switches involved with the BMS, or the battery management system, and the batteries themselves. If you look over to slightly to the right, Sunny, and zoom in, this is our battery management system. From what I understand, I think we actually do have a picture of this. We'll have to pull it up in a little bit. We'll have to explore to find it, but it's pretty cool. It's like pretty much a housing for it. It has fans to keep them cool, and stuff like that. You can go ahead and go more to the right if you'd like. And we have a series of things that are important to us. We have horns. Pretty much it. We have a horn there. Go ahead and go down. Now this is one of the big things. So when we hit into driver interface and into telemetry, we have the CAN system. And if you'd like, Nathaniel, if you'd like to speak about the CAN system or about driver interface things, you're totally cool if you would like to.
Sure. I guess since we're just going over basic concepts at the moment, we're not really getting into a lot of detail. If anybody here has done anything with regards to serial communication, that's essentially what the CAN bus is. You get the same kind of communication with your USB ports. If anybody has done anything with like an Arduino Uno or microcontrollers communicating through UART or SPI or I2C, it's the same thing. But it's the only real difference is that there's no master-slave relationship. Every node basically arbitrates which one goes first. So serial communication is basically the opposite of parallel communication, where you have many nodes branching off of like a single, say, microcontroller. I'm assuming most of you have at least seen a microcontroller where it's like a little black rectangular box that you would put, like, say, on a breadboard, and it's got a bunch of nodes on it. You can have like 8 of those nodes represent, say, an 8-bit binary string, and you can connect that to another system. And if, depending on like which of those wires are high and low, you'll have a different message being sent out. With serial communication, it's that, but under a single wire. So essentially, one wire will be communicating between 2 microcontrollers in this example. and one of them will talk to the other one by sending out a signal that's like, say, high, low, low, high, low, high, low, low, high, and that will be interpreted by the microcontroller. The CAN bus is essentially just two wires in parallel, and then different nodes will attach different electronic devices to that node, and each one will take turns talking to each other. So that's the basic gist of what the CAN protocol is.
All right, perfect. That sounds great. Very informative. Thank you, Nathaniel.
Mm-hmm.
Go ahead and scroll a little bit more, I guess, downwards. We have to look at our lights eventually, and this is our system for our lights. We have flashers. Sorry. Okay, so we have turn signals pretty much for both the front and the back. And we have brake lights over here. We have a headlamp over towards the left a little bit. And if you scroll a little bit more over to the left, we get to see the motor. Our motor controller, sorry. The motor's more towards the right. But yeah, there's the motor controller. This is pretty much our Pi, right, Nathaniel? This is what our Pi is supposed to be doing.
Hold on, let me look. Can you point it out real quick?
The Mitsubishi motor controller, or is that something else?
I'm not entirely sure what that is or what it does.
So no worries. Yeah, no worries. So some of the things, like I mentioned before, we are still learning as well. So I just need to talk to the last person that actually did this revision to find out a little bit more information about it. So when I find out, I'll let you guys know. And then if you just go slightly above and to the right, we just have a DC-DC converter. I found out that the MPPT actually acts as a DC-DC converter as well. So that explains some things when I was talking to Nathaniel. So that's pretty much the overview of the schematics that we're going to look through. But there's some more things that I can look through. I'm actually going to have Sunny, you can go ahead and unshare your screen, and I'll share my screen in a moment. Right. Is everybody able to see my screen? Share drives. Thank you, Chloe, for answering that. Gonna go into solar car. Gonna go into electrical, and we get to find some cool things. Besides schematics, which is a really big one, actually. Besides schematics, which is a really interesting one, we have like stuff that we need to check out with batteries. So, not that one. Sorry, I was looking at them earlier. They were set up on my tablet. It was a mistake to try to do both. Is under... Batteries? Yeah, there we go. So here's the battery management system, like I mentioned before. I believe somebody just 3D printed this, and this is pretty much the battery cell that you saw earlier. You're gonna have them stacked up. You're gonna have fans just like you had in a computer, just to keep them nice and chilly. Really cool if they added that in there. More about the battery management system. Here's more information about specifically the solar array and all that sort of stuff. I'm actually going to cut it off right there. If you'd like to look in here, please feel free to. It was actually this one that I think about it. No, it wasn't. Okay. Yeah, you could just look through here. If you don't have access, like I mentioned, put your email into Discord, and we should be able to get you access to that. Sunny, I'm gonna stop sharing my screen. Go ahead and go pull up the PowerPoint where you can finish that off.
Cool. Let's see. Um, was it the
All
slide?
right. Perfect. Yeah. So this is our next section. This is we're doing objectives now. As many of you know, we're in a pandemic, so we're not physically able to work on the vehicle at the moment. There are some things that can be done, but mostly it's mechanical and telemetry and driver interface that are able to do those things. But we are helpers. So if you feel like you would like to expand out and pick another subgroup as well, please feel free to. It's nice to learn extra bits from other sub teams as well. What this is basically what we're going to be doing is I'm going to be prepping you for when we're able to work on the target. We're going to be going through things like P Spice and soldering and LP Spice, embedded systems, and stuff like that along those lines. And that'll be there's a meetings list coming up talking about the dates in which we're doing these things. When we are allowed to get to the vehicle again, our first task is going to be making sure everything's working properly to make sure that some of the battery cells that are in the solarium aren't damaged or stolen or anything along those lines. We're also checking like solar panels and stuff like that. Lastly, the last thing that we're kind of planning out is we're going to be routing the wires so that way we kind of have an idea. And Sunny, if you want to pull up those images that you showed me earlier,
Yeah, sure.
we can kind of give them the idea of like the size of the vehicle and kind of like why we're currently right now we're working with the chassis, and that is it. We just have a chassis, and all the components are off that chassis. We're waiting for the shell to be fabricated and put on.
Yep. Okay, so this folder is actually a .zip file you can find in the mechanical 2020 to 2021. Actually, let me just share my whole screen because I'm gonna be opening up this stuff. Okay, so let's look at this first. So they have the whole solar car. I think everyone's seen that one so far. So we also have one that shows where the batteries are located, which is here. You can see there's 3 packs in there, and that's how the driver is situated in the car.
It is very cramped. When I saw that chassis, it is tight.
Yeah.
I don't know who's driving this thing, but it's tight.
Oh yeah, we still need to find someone to drive it when we're done. Okay, I think that's about all the information you can get in this folder. There's another view. There's one with more detail that labels everything. Drawings. Yeah, right. So this one is like it shows more a more transparent view. So you can still see the battery pack. There's a ballast over there for I believe it's to balance the weight of the batteries. There's top view. And there's not really much of the electronics in this model, so I guess we'll put those in later.
Yeah, that's what we're going to be probably doing is mapping those out, because if we don't and it gets put together and nothing quite reaches, then we have problems. So go ahead. You can go ahead and go back to the slides.
Yeah.
So yeah, like I mentioned, those are our objectives. And then the next one, these are our future meetings. They're going to be set up every 2 weeks, but it's tentative. If we're having like a lot of people having exams, or if I'm going to have an exam, or Jenny's going to have an exam, we're probably going to delay it either a week or a new date will be chosen for that. But these are the topics of which we're talking about. Like the next one will be October 8th. We're talking about P Spice and LP Spice Basics. Also setting up your ENGR account if you haven't already for some reason.
I'm really sorry to interrupt, David. Did you mean November 8th?
Yes, I did. Ignore those. Yeah, just. Oh no. Okay, I'll figure that out. I'll update those before I upload it. But yeah, those. Thank you, Nathaniel. Um, yeah, I'll refigure out those dates and I'll have it sent out. It's probably November 8th and November 22nd, and like, go ahead and hit the next one. And these are miscellaneous things. Our biggest concern to you guys is your grades and your health. Do not do anything to jeopardize both of those things. Not come to campus. Should try to work on the car for some reason. Don't unless like you're cleared or you're following protocols like that. Also, yeah, like your grades. We want you to have really good grades. We don't want this project to ruin that. So please focus on your schoolwork as well. And if you have time for us, please come on in and help us out. Okay. The second thing, neither myself or Sunny are here to tutor or help with homework. It sounds kind of mean. I don't mean it to be mean. Like it says on there, I literally have too much homework already. I really can't help you with yours as well. We're both new leads. Sunny and I are new leads. If you have any feedback, please, I would love to hear it. Even if it's critical, I don't mind. And then lastly, like, reach out to us. If you don't, like I said, if you don't know a task, please just reach out to us. It's not a big deal. Our meeting is coming to an end in about 10 minutes, so I'll start accepting questions after this. Last thing though, I just want to make sure, due to the frequency of our meetings, self-learning is highly encouraged, and it also should be highly encouraged outside of projects in general. If you're interested in something, please jump into it. All right. That's the end of this. If you have any questions, please either type it in chat or ask. I would totally love to answer them if I can.
What does solar array do?
Solar array deals with the solar panels and the links between the solar panel and the battery.
So then, does the solar array group work closely with the electrical team?
Yes, we actually are helpers, pretty much. Like, think of us as like Santa's elves. So we deal a lot. We work a lot with telemetry, with I believe driver interface, if I remember correctly, battery and solar array.
So then, is it a good idea to be part of both teams, or is that too much work?
No, no, it should be fine, especially since I'd probably be sending you over there to help them anyway.
Okay.
But at least you'll be able to, like, you can already attend their meetings and stuff like that, but like at least you'll be more of an official capacity that you're in.
Yeah, if you're interested in any team, you can go ahead and check it out. The meetings are pretty much open.
Can I add something to that real quick, actually?
Definitely.
So I'm the lead for driver interface, and since we will be working together a lot of the times, one thing that I actually encourage people on my team to do is to actually come into the other disciplines. Hold on one second. So sorry about that. So I encourage everybody in my team to go into the other team's Discords and introduce themselves and be like, hey, my name is this. I'm working with this discipline, and I'm mainly working on this. If anybody needs any help or they need any clarifications on what we're doing, and then try and be a bit more, well, what's the word when things are like working really well in tandem together? Anyways, so yeah, if you sorry, my brain's not really working that well right now. But one thing I would actually encourage you guys to do is to also reach out to the other Discord channels. Not necessarily the voice channels, but like the chat channels. Just go in there and be like, hey, I'm here, I'm from, this is my name, I'm from electrical. If anybody wants any clarifications on anything, if anybody has any ideas on how they want to implement their stuff, we're here to help. So yeah, reach out to me if you have any questions. So I would highly recommend anyone do that.
You don't have to think of yourself only on electrical. Think of yourself as a part of the whole solar car team. Okay. Any other questions you might have for us? We have about still 6 more minutes for this meeting.
I have a question actually. freshman and I don't really have that much experience.
Yeah.
Is that okay? Or
Yeah, that's totally all right. That's actually what I was mentioning before. So on the last slide, Sonny, if you can go back one slide, these are basics that you will pick up more towards the beginning, but they're basics that are important for us. So being able to know how current's going to go down the line, like what will happen. You'll learn that kind of stuff in E001A. You'll also be learning it in PSpice as well. Like you can actually like map things out before you actually wire them up, and it kind of like helps you understand what's happening. They also have simulation, which is the second week after. Still more that's over. Um, but yeah, it's all pretty much what we need. And if you don't know it, like I mentioned before, just ask. We'll help you find out whatever it is that you need to know, and usually we'll teach you.
thank you.
All right, no problem. I do have a question for y'all. What are your majors? And yeah, that's it. What are your majors? And we're definitely going to be asking about skill sets for the next 5 minutes, just to see where you guys are at.
So for me, I'm a EE major. And what was the other thing I was supposed to mention? Sorry.
If you have any skill sets, like have you programmed before? Have you wired a board before? Have you soldered anything like that?
Yeah, so I was in Micromouse for 2 years. Right now I am a third year, and
Nice.
I know how to solder, um uh PCB designing too. Since my second year of Micromouse, I used Easy EDA to PCB design.
Okay.
Soldering is something I know. I know coding since as a EE major you had to take some coding classes.
Mm-hmm.
Um, I've used PSpice before for EE labs. This quarter I'm starting to use LT Spice for my EE 100B lab.
Okay. Oh, we're in the same class. Nice.
Oh wow, really?
Yeah.
Oh, I didn't know that.
Yeah, I'm in 100B also.
Oh, nice. Now I have someone that I could study with.
Yeah, for real. That class already.
Oof.
Get out of here with that.
Yeah.
All
And
right.
yeah,
That sounds good.
that's a
Thank
bit
you.
about me. Hmm.
How about Chloe, since she's next down the literal line of names for me? Chloe,
Well,
would you like to? Go
I'm a
ahead.
computer engineering major, and I mean, I don't have advanced skill sets, but I am familiar with coding in Java and C++.
Okay.
Yeah, that's it.
Nice. Those are really good to have, especially you said CE. I think there's some crossover for EE and CE classes, specifically the 120 series, like 128 and 120B. Those will be great for you to have. Good on you. We might actually probably will have Nathaniel borrow you for your coding skills as well.
Great.
Easy on the freshman. Okay, electrical engineering. I know how to use CAD, SolidWorks, a little wiring, do my device. Oh, very cool. I like that. You're gonna fit in real nice in your Daisy, specifically because you've already done robotics. That's pretty cool. That should give you a good heads up about interconnected pieces and stuff like that. Is there anybody else? Oh, we got Peter in here and Kevin. Oh, there's a whole slew of people I didn't even see. Kevin, buddy, how are you doing?
You might be muted.
He might be muted. Peter.
All right. So, hi everyone. I'm a second year EE student currently, and I have a little bit of experience with circuits and C a little bit. I know C++ until it gets to classes, and then I get confused.
I feel it. I feel that. No, it's great. Good to know. Yeah, like I've taken a lot of coding classes. They still bite me, but you just get through them eventually. It just happens. Daisy already answered. I think I talked to Kevin. Kiana, how are you doing? All right, no worries. No, I don't have to put anybody on the spot. Oh, she answered. Never mind. I put you on the spot.
1 minute left.
Yeah. Oh God, I gotta read these real quick. Okay. First year, PE, also robotics, nice. This is in SolidWorks, CAD, and knows some skills on wiring, so that's perfect. Kevin, freshman, currently in chemical engineering, but I plan to switch into EE hopefully. I feel that. I actually had a friend that wanted to switch over from biology over, and they just would not let her. I'm assuming because it was outside of PCOE. Oh, nice. Do y'all go to the same high school? Is that how you know? How you know about robotics? Yeah, nice. That's cool. All right. Well, we have. Let's see.
Less than a minute. So we're
Less
probably
than
gonna
a
get
minute.
cut off anytime now.
So.
Bruh. I guess that's it. Thanks for attending our first electrical team meeting.